Thank you for joining me. Welcome to TJ's Maths Clinic. Still on Senior School Certificate Examination, NECO 2025. With us here is General Mathematics Paper 2, question 9A. Let's consider this question. An aircraft took off from an airstream with an average speed of 35 km per hour on a bearing of 015 degree for 2 hours. It then changed course and flew on a bearing of 100 degree with an average speed of 22 km per hour for another 2.5 hours. We are asked to find its Roman numerals 1, distance from the starting point to 2 decimal places. Roman numerals 2, we are asked to find its bearing from the airstream to the nearest degree. Of course, this is from bearings and distance. If we observe this question very well, speed is given, time is given, but distance is not given. So for us to interpret this question, we need distance because we are talking about bearing and distance. Very important. So the first thing for us to do is to get the distance at each instance. When it is 35 km per hour for 2 hours, what will be the distance? When it is 22 km per hour for 2.5 hours, what will be the distance? So let's write down the solution and find distance. Speed is distance divided by time. In other words, average speed is nothing but total distance covered divided by the total time taken. Very important. And let's say this is our first speed, first distance and time as well. Our speed is 35 kilometer will be equals to d1, that's the first distance we don't know, for 2 hours. Is divided by 1. So d1 now will be 35 times 2, we cross multiply now. That will be 70 kilometer. The first distance is nothing but 70 kilometers. So let's move to the next point. The next speed, next distance, next time. Next speed is 22 kilometer per hour. Then the distance 2 is not given. Then the hour is 2.5 hours is the same thing as 5 divided by 2. Then we cross multiply. Distance 2 now will be 22 multiplied by 5 divided by 2. Of course, this will be 22 times 5 divided by 2. That will be 55 kilometers. So D2 is 55 kilometers. So these are the two key information that we need for us to interpret this question. So let me take it up. Our first distance, 70 kilometers. Then our D2, which is the second distance now, is 55 kilometers. Very important. So permit me to clean this so that we can sketch now. We see how the interpretation of the question is going to be now. Very important. So suppose we have our cardinal point like this here. We have the North Pole here. An aircraft took off from an airstrip with an average speed of 35 km per hour on a bearing of 015 degree, that's 15 degree. So suppose this is where we have our 15 degree. Let's say it's like this. Let me take this distance. D1 70 kilometers, D2 55 kilometers, so that we can have space. Let me extend this to this point. Then we'll have another cardinal point, of course, here, like this. Or let me reduce it. Let me reduce it to this point. Suppose we have it like this. And then we have another cardinal point here. We have the North Pole. Of course, this will not be 015 degree, and this is 70 kilometers. This is now the airstream. Let it be A or airstream. Let's leave it like this. Then let this point be B. This is the movement now. Then it now changed the course and flew on a bearing of 100 degree. from this north pole to east is 90, so 100 degree will fall here. And this is 55, so it will be shorter than 70 kilometers. Very important. So let's say we have another cardinal point like this here. Of course, here will be 55 kilometers. And from this north pole here, this is our north pole, then we have 100 degree now here. Very important. Then the next thing now, let's say this is point C here. The next thing now is to connect this. Care must be taken. If we are to start above, that's above this, we will end up below. Very important. So it means if I'm to start below, I will end up above. Of course, I have to start above this cardinal point, meaning I will connect it like this to this point here. So starting above, I will end it below at the other card. Below in the sense that below this other cardinal point here. So this is how to connect this. So this is said to be the interpretation of this question. Very important. If here is 15 degree, it means this angle too will be 15 degree. And from this north pole to this south is 180 degree. We have removed 100 degree. The leftover angle here will be 80 degree. So we can find the total angle here now, which is 80 plus 15 degree. That will be 95 degree. Very important. And the question says find the distance from the starting point. It means the aircraft is at point C now. We are asked to find the distance between the airstream or like the airport, where that's the starting point now. So we are looking for the distance between the airstrip and this point C. So this is B, small letter B is facing this, C, then this is A. So we are looking for the distance AC per se. Our A represents the airstrip. Very important. So two sides are given and the included angle. And that included angle is not a right angle triangle. So we have to use cosine rule. Very important. When two sides are given with the included angle, then we apply cosine rule. So we can say using cosine rule, we can establish the fact that b square will be equals to a square plus c square minus 2ac cos capital B. So this is the formula we're going to use. So B, we don't know our B square. This will now be equals to A. Facing A is 55. That will be 55 square plus 70 square minus 2 times 55 times 70 cos angle B, which is 95 degree. Very important. So this is 95 degree. Let me write it well. This will be cos 95 degree. So let's use our calculator. B square now will be equals to 55 square. We have 3025 plus 70 square means 4900 minus 2 times 55 times 70. What do we have? We have minus 7700 multiplied by cos 95. Sure that your calculator is in degree. Of course, it will be negative. That will be negative 0.087172 approximately. 72 approximately. So let's simplify this further. Permit me to clean this part of the question up to this point so that we can solve for that distance. So b square now will be equals to, we can sum this, that's 4900 plus 3025. We have 7925. When I say minus times minus, of course, will be positive. Then we multiply 7700 by 0.0872. Very important. What we have? We have 671.44. Then we sum this. B square now will be, we can add this now, plus 925. What do we have? 8596.44. To find B now, we take the square root of both sides. 8596.44. B now will be the square root of 8596.44. What do we have? We have 92 92.7170 approximately, because the next number is 9. So we have 7169, then we have to add another one. So this the distance now. The question say the distance from the starting point. The distance from the starting point now, the distance now, the distance from the starting point will be equals to, and to 2 dp, to be 92, this is in kilometer, it will be 92.72 kilometers. Very important, to 2 dp, 92.72 kilometers. Very important. Let's move to Roman numerals 2. The bearing. The question says the bearing. Find its bearing from the airstream to the starting point. It means the bearing of the aircraft from the airstream. That's what we are looking at. Permit me to clean this question, this part here. Permit me to clean this so that we can look at the next question now. Solution to Roman numerals 2. The bearing now, it means, let me extend this. This is our North Pole here. This is the angle we are looking for. The bearing of the aircraft now is at this point, C here. So the bearing of this aircraft from the starting point indirectly. So let this angle here be theta. Very important. Theta plus 15 degree will be the bearing of the aircraft from the airstream. Very important. So let's apply sine rule. Using sine rule, well, we apply sine rule to find this theta. So it will be 55 degree now. The angle, the side facing this theta divided by sine theta will now be equals to our B will pick the 4 dp now. That will be 92.7170 divided by sine what? The angle B now is 95. That will be 95 degree. Then we cross multiply. This will be 55 sine 95 degree will be equals to sine theta times 92.7170. Very important. So let's resolve this. So ensure that your calculator is in degree. So sine 95 degree multiplied by 55 degree. What do we have? We have 54.7907 will now be equals to sine theta times 92.7170. Let's take it up here. Our aim is to find theta. So let's divide both sides by 92.7170. So sine theta now will be 54.7907 divided by 92.7170. What do we have? Divided by 92.7170. So sine theta will be 0.59009. So theta now, of course, will be the sine inverse of 0.5909. So what will be our theta? So we are looking for theta now. Let's clean this so that we can find theta. Theta now will be equals to, press our calculator, we press shift, then sine inverse of 0.5909. What do we have? We have 36.2209 degree. So this is our theta. The bearing now, the bearing of the aircraft from the starting point, or from the airstream starting point, will now be equals to 15 degree plus 36.2209 degree. What will be the final answer? Plus 15 degree. We have 51.2209 degree. Finally, to the nearest degree now, the bearing now will be, to the nearest degree will be 51 degree. That is to the nearest degree. So the bearing is 51 degree to the nearest degree. That's the solution of 51 degrees. So this is said to be the solution to this question. Thank you for watching. Please do share this to your learned colleagues, and don't forget to subscribe to TJ Smart Clinic for more interesting videos. In my next video, God's willing, we'll look at 9B, question 9B, before 10, 11, and 12 in that order. Thank you for watching. See you in my next video.